Let's look at this question. A rectangle with sides 2m-1 and 2n-1 units is divided into squares of unit lengths by drawing parallel lines, as we can see it in the diagram. Then what is the required number to find? The number of rectangles possible with odd side length. So the most important thing is the length of the side of the rectangle formed should be of odd side, right? Now let's number the horizontal lines as line number 1, line number 2, the line number 3, then line number 4, 5, 6, like this. There are how many lines? Total 2m-1 lines are there. And similarly, the vertical lines are numbered as 1, 2, 3, 4, 5, 6, 7, and this would be the 2n-1th line. So there are odd number of lines horizontally and odd number of lines vertically. Now look at the requirement. The required rectangle must be of odd side length. Yes, if we divide the rectangles into subcases, then what will happen is we need to find out different sides as 1/3 rectangle, 3/3 rectangle, right? That will become a bit complicated. So let us see what we are doing here. For the length to be odd, right, we need to select one odd numbered line and one even numbered line. Now let's understand what do we mean by this. When we select one odd numbered line with one even numbered line, then what is the length of this rectangle formed? That will be 3 units, right? When we select any one odd numbered line and one even numbered line in this total 2m-1 lines, then the length of the rectangle will be always an odd number, isn't it? Now, how many ways can we select one odd number line? Yes, for that I must know how many total odd lines are there. If you look at total 2m-1 lines, there will be m odd lines will be present. So odd number line from m odd numbered lines. And similarly, how many even number lines are there out of this 2m-1? Yes, the remaining m-1 lines after separating the m odd lines would be even numbered lines. So there are m-1 even numbered lines are there. Now, how many ways can we select one odd line out of these m odd lines? Yes, that can be done in mc1 ways. Similarly, from m-1 even lines, how many ways can we select one even line? That can be done in m-1 c1 ways. So one odd line and one even line is selected, then definitely length of the rectangle will be an odd number. Now what is for the breadth to be an odd number? Now again we need to select from vertical lines now. Now for the vertical lines, the side length to be odd, what do we need? There are total 2n-1 lines. Then we need to select one odd numbered line from how many odd number lines are there? When there are total 2n-1 lines, there will be n odd numbered lines will be there. We need to select one line out of this, and the second line that we select must be from an even numbered line. Now how many even numbered lines are there? Out of 2n-1 lines which are vertical, yes, out of them n are odd, then the remaining n-1 even numbered lines are there. So how many ways can we select the vertical lines? One odd numbered line out of n odd number line can be selected in nc1 ways, and by fundamental principle is into the one even line out of n-1 even lines can be chosen in n-1 c1 ways, right? So the value of number of selections of breadth rectangle should be n times n-1, and the number of selections of odd length of the side would be m times m-1. Then what is the requirement now? A rectangle is formed by selecting both length as well as the breadth. So shall we conclude? Therefore, the required rectangles is selections of length that can be done in m times m-1 ways into and the selection of breadth that can be done in n times n-1. So which option is it satisfying? Yes, the option D, which says m into n into m-1 into n-1. So here we have avoided the different subcases of different possibilities out of, because we don't know the fixed number. We have 2m-1 and 2n-1 line, right? You can also practice taking even number of lines on either side. Similarly, you can practice taking the rectangle to be even side, right? Different possibilities arises out of this for practicing, right?